Hello everyone, welcome back. Today we're gonna learn about Linux file system structure. This is our hierarchical or directory hierarchical in our Linux system. The topmost directory is known as root directory, okay, which is we can say as slash. We can say root directory as a slash. This is our topmost directory. Every directory is inside our root directory. So it is a top level directory. Every file and folder in Linux exists over here. So if you go to our terminal, right, if you go to our terminal and do ls/, ls is our command which is to see a list. So if we do this, we'll see a bunch of subdirectories which is inside our root directory. Okay, this is different than our /root, which is a directory in itself. Well, slash is our topmost directory. Okay, so next we'll move to our bin directory. Okay, /bin. Bin stands for binary. It is essential user command. It stores executable program that are required for the system to boot, are needed by all the users, must work even if the user is not mounted, are used before login or rescue mode. So these are not the files or config, but they are programs. So why do we need /bin? Well, in our old Linux or Unix system, the disk space was small and system booted in different stages, and /usr was in our separate disks. So Linux needed a place to store a critical command, right, that had to work immediately. So that place was our /bin, which is our /bin. So what are stores in /bin? So there are view files, move, copy, delete command, read text command, start a shell command, repair or fix broken systems. So if we do ls do /bin, so if you do this, we'll see bunch of subdirectories which are in our /bin command, right? So basically understand it by thinking like ls, cp, mb or rm or cat command. They all are in our /bin command. Okay, so these are all listed in our /bin command. Another important command that are listed in /bin are chmod and chon. Chmod is used for fixed permission, and chon is used for ownership. Okay, so why bin is critical? So why /bin is critical? Because imagine if your PC is broken, or your machine is broken, your GUI is also broken. So you have to boot into a recovery cell, so you would need a ls or a cat command, right? So you want that, you would want to move your backup configuration to a original configuration, or original configuration to a backup. So these are the work which is used without /user. So that's why /bin is used. Well, in our modern Linux, in our today's modern Linux, disks are large, right? So /user is found in all the boot states. So Linux developed a merge directory. So if you go to your terminal and do ls-l, you will do ls-l, you will do bin. Okay, just do this, you will see /bin is pointing to our user /bin. So this is what you call a merge, usr merge. Okay, so what you can understand this is, so /bin is just a mere location file. So it's just a symbolic link that is pointing to our usr/bin. So the real command, the real physical command which are stored are in usr/bin. So when you just do ls/bin, it will show you the subdirectories or folders which are in usr/bin, but the actual command are being stored in usr/bin. So So why do we need bin then? So as we know, the many scripts, old scripts, still when they execute, they source for /bin. So so that's why we need /bin, and well, for our modern system usr/bin is used. So if we remove /bin, then our system would break. So today Linux system keep them as a link, not as a storage. So what is usr/bin, right? So this is a real folder. So every executable program are physically stored here, where it be a Python, Git, ls, cp command. The actual bit and byte live inside this usr/bin. Okay, so if you do ls slash, right, here you will see sbin.usr is merged. So what is this? So this is nothing but is just a marker file, right? So it is a note saying that, hey, I have already moved, so folders in /bin to a usr/bin and set up the shortcut. Don't try to move that again. If you try to move that again, your system may get fogged. They will occur in conflict. So it's just that. So /bin is /bin.usr-is-merge is our marker file. It's nothing more than that. Okay, so now let's move to our second directory, which is sbin, this one. So sbin is a system binary. It stores administrative command used to boot the system, configure hardware, manage disks, manage networking and kernel, repair a broken system. So these are mainly for the administrative use. Normal user won't usually use that command. Okay, so why do we use sbin? Is like it is used by a root user, system admin. So if your system goes to a recovery mode, then the sbin is used. So normally user won't use it, we know that. So sbin command are used to configure, control the hardware, control system status, modify kernel behavior, bring the system up. So these comes pre-built. Okay, so this comes pre-built. So some of the examples that I use in sbin is, so if we see what is an sbin, right? So if I do this, you'll see bunch of subfolders again. So again, subfolders. The command used in sbin are usually like fdix, fcsk, right? So if fdix, if you do this, so fdix and fsk, mount, ip, right? So if you do ip and if config, okay, so if config, right? So all those things reboot. So these are the sp command. Okay, so here do this sbin do fdix, right? So this is just printing. So just let me try this. Okay, okay. So so basically so sbin command are critical. Why it is command? So imagine if your system crashes, a file system is corrupt, Linux drops into a recovery mode, then sbin are usually used. Okay, so in modern Linux, sbin is a symbolic link. So like that we did for /bin. So it goes same for our sbin system binary. So if you do this -l /sbin, right? So sbin is pointing to our user /sbin. So it's the same case. The real command is stored in usr/sbin. Okay, so why does if you try to like in sbin commands, like some of the command requires sudo, right, and some of the command usually don't require sudo. So you have two reasons to decide sudo when sudo is required, right? So there's a statement like, does the command modify the system? If yes, then sudo is required. If no, then sudo is not required. Another case is, does the kernel allow non-root access? Then the kernel enforces permission checks, and some operations are root only by design. So if it matches this two condition, then the sudo is required to be used. Okay, so for example, so here if I do if config, right? So if I do if config, then I won't require a sudo. Okay, so I won't require a sudo. But if I have to do if config eth0 down, right? So if I have to do this, so what it usually happens is, you will require a sudo, because if you that command disables a network interface. So it affects the system networking. Okay, so this eth0 may determine the Ethernet interface that is en2ps0. I've used this as an example, don't get confused. So this is where you require a sudo. Okay, so if you want to know, another important thing is, like, if you want to know where your command belongs to, just type where is fdix. So where is fdix? Then see, fdix is in us has been fdix. So this is where fdix is in. So this is basically that. Now let's move to our another directory, which is slash bin. So slash leave, this one. So leave this. So this is so this is our library. So it contains a critical shared library. Okay, leave contains a critical shared library or libraries. So essential command like slash bin, sbin, so it depends upon a slash leave. Okay, so without slash leave, your Linux can't even start properly. So example, your ls doesn't contain everything within itself. Okay, so it depends upon the library like leave c.so, leave se linux.so, leave ps-thread.so. those library live inside slash leave. So if you do leave, okay, you'll see bunch of folders. Again, you'll see bunch of folders. So these library live inside slash leave. Okay, so why does slash leave exist separately? Early boot problem. So during boot, slash usr may not be mounted yet. So Linux needed libraries available very early. That's why slash leave exists. So what is exactly stored in slash leave is there is a shared library. Okay, there is a shared library like you might see there are the shared libraries. If you open this any folder, you might get a libraries. So like you might find lib slash x28. so basically these are required by ls, bash, mount, and more. Okay, so these are the libraries. So let's check how other command uses library. ldd, type ldd is a diagnostic tool. Okay, so do slash bin slash do ls, we will find what ls uses a library. Okay, so if I do this, come here and see, so our ls uses libsc linux.so.1, which is used by which is in our usr slash leave, which uses this library. So our ls uses library this one. So this is how we can say that our slash bin depends upon our slash leave. Okay, so what happens if our leave directory is broken or missing? Then you might get an error like no such file directory found. right, you might get an error like /bin/bash while loading shared libraries cannot be opened, shared object file, like that. So that's why our leave directory is very critical. So you might even see, when you do this, you might get confused, or you might see lib64. So these are present if your machine is of a 64-bit, right? Okay, so it often exists on our 64-bit. So again, it goes for same. So if we do ls-l, we'll do leave, then we'll get our leave pointing towards our user/bin. The same, it is a symbolic link towards our user/leave. So you'll get this. Okay. So why normal user rarely touch leave? So because editing library can break system. Library are managed by package manager. So if you manually change them, then it is dangerous to our system. Only system and package manager should modify /leave. Please do not use this /leave, which is our library directory. So now let's move to our next directory, which is /usr. So this is our user system resource. So it is or you can say a Unix system resource. It contains a program, documentation, libraries, shared system resource. It is used by all the users. It is not a personal file. It is used by all the users. So why /usr is used? So after system is up, or after your system is up, it is used for our daily operations. Okay, so so our /bin, /sbin and library, it exists for our early boot stage. But when you're performing, when your system is when you're working on your system, then /usr exists for that reason. It is used for normal operation. Okay, so if you open, so if you go to /usr, right, you'll see bunch of subdirectories. You'll see directories like, you'll see bin, you'll see game, include, leave, share, right, you'll see man. So you might also see man here. So these are the subdirectories you'll see inside your /usr. So let's go for our /usr bin, which we discussed earlier. So here every executable files are over here, and once we go to our sbin, so right, your system administration command are over here. So, and if you go to our leave, then obviously you will have a libraries that our bash or our command use in our system. So these are here you will see share. Okay, so /usr/share. So this so it contains a documentation, icon, time zone, man page, local page. So if you expand this, right, so usr share. Okay, so if you expand this, you will see bunch of subdirectories, and here it contains an icon, documentation, time zone and all. So here this is no binary. Okay, this is not a binary, this is only a data. So this our /share is our architecture dependent. So what is architecture dependent? So architecture independent, it is an architecture independent. So program in /usr/bin are architecture dependent, meaning a version from an Intel chip won't work for AMD or AM chip. But data in usr/share is an architecture independent. A text file, icon or a time zone look exactly same for all the computers, regardless of the processor. So that's why our /share is our architecture independent. Okay, so it is an architecture independent. So what lives in there? So if you run ls/usr/share, which we did, you will see bunch of folders which we already saw. Okay, so our /usr/slash is one of the biggest directories on our Linux. For example, so if you install a game, right, the code runs on a /bin or a small part. It may run on a /bin or usr/bin, right, but the texture, the music and all goes to our usr/share. Okay, so let's explore some of the folders which is inside our /usr/share. So if we do usr/share, let's do our zone info. if you do this, you'll see bunch of continent, you'll see GMT, you'll see local time, you'll see bunch of folders. I'll just go for Asia. Okay, okay, this is case sensitive. Okay, if I do this, I'll see bunch of the cities which if we expand this, here is the time zone for that particular city, right? So this is the use of /usr/say. Now let's move to our another subdirectory, which is our /usr/header, which is a header. Here is just it is used for C++ development. It is used for GCC and compiler, and here you will see a local usr/local. Okay, so it is basically locally, it is used for locally installed software. Software installed manually, not managed by package manager. Okay, so if you do local, you'll see bunch of files again. So if you you'll see bunch of folders again. So why do we have bin inside a local? You might want to know, right? So Linux keeps its factory installed gear separated from the manual installed gear. So the factory installed that are the app that will come with your Linux distro is installed in our bin. But when you install a third-party software app manually, if you install manually, then it is stored in our usr/local.bin. So it is used for that purpose. So Linux keep them separately as a so in order to get them mixed up, it is used usr/local/bin is used. For example, if you have installed nmap, which I have installed in our PC, which is third-party script, source and compiled, so it lives inside usr/local/bin. But the important thing is you might see it in usr/bin if you have, like, if I do bin. Okay, if I do bin, then I might see nmap. Okay, let's check. See, nmap is located in my usr/bin because I've installed by using sudo apt install nmap, which is already in our Debian or apt store, right? So if I open okay, so my bad, if I do ls usr, which is in local, okay, if I do this, if I go to my bin, right, I'll see Browsuite community and packet tracer, because neither Browsuite and packet tracer are part of the standard Ubuntu Debian factory. Okay, so I downloaded this from a Portugal website, and I downloaded this by Cisco packet tracer website. So I installed them. So we know that if we install third-party software that doesn't come from our official apt store or a snap store, the installer are programmed to put the executables in our usr/local/bin. Okay, so this is an overview of our directory /usr. Now let's go to our another directory, which is our etc, one of the most important directory, I would say. So it contains a system-wide configuration file. Okay, so this file contains it contains control system behavior, control services, control user networking security. So these are usually in our plain text. There is no binary, no program. It is usually in plain text or a configuration, only configuration. Okay, so why /etc exists? So Linux uses two rule. Okay, so program lives in /bin or usr/bin, configuration lives in /etc. So you might get confused. We already have /sbin. So why do we need /etc? So /sbin, it is used. It is for a root user, a super user. So it comes with the Linux distribution when you install. So /etc it is used for a system configuration directory. It is editable. We can edit the configuration file in our /etc. So that is the difference. So it allows easy customization, easy backup, easy troubleshoot. So who uses /etc? Usually system administration, package manager, they use /etc. So never delete the file from /etc blindly, because you might break the system. Your Linux machine won't answer properly or won't even start, for that matter. So what actually lives inside a /etc? So if I do ls/etc, right, see, I'll get a bunch of folders again. I'll see many files. You'll even see a file like passwd, you'll see hostname, PAM configuration, every folder and file, right? So let's see the use of our /etc. So first we'll see the use that is used in our user and authentication configuration. So we'll see that in our passwd. So it is this our /etc/passwd. Okay, so this shows our username, user ID, home directory. So if you run this, so if you open this, you will see permission denied, right? So like we discussed earlier, you will need a sudo permission so to run this. So if you open this, okay, so if you open this, okay, so I mean, if you open this, you'll see you'll see an example. Like if you open this, right, you'll see like a root. Let me try this one more time. Found. Permission denied. Let's try with ls. I mean, it will give the same thing. Okay, so what you have to do is you have to use a cat command. I just forgot because this is an read-only file, right? So you have to use a cat command. My bad. So if okay, so the permission is denied, we got that. If you use a cat command, you'll see this one, right? So what is actually this is the root. This is your username, and after the same after a colon, you will see an X, which is your password that is stored in user etc/shadow. We'll discuss it later on. So 0, this is your user ID, this is your ZID, this root is the header, this is your header directory, and this is your logic cell. So you will see this. Now you will see file like game, you will see game, daemon, bean, sync. You will see this. So these are the system user file created for service and security isolation. If you come to our game, you'll see no login. So what no login means is this: a user cannot log in. Account exists only to run a service. Okay, so this is these are the files that you will see in etc/passwd. Okay, now let's move to our etc/shadow. Okay. Okay, let's go to our shadow. So etc/shadow. So it stores encrypted password policies. It is root only access. So while etc/password pd list all the user, it actually is a public acknowledge. Only on the system can on anyone on the system can read it. Okay, but in etc/shadow, it is where all the real secret live. If you run, right, for this you have to run sudo, as we discussed, it is root only access. So if you do sudo cat dot etc sudo cat /etc shadow. Okay, if you do shadow, see, you will see bunch of you will see files separated by columns. Okay, so here MySQL for this, so here these are the lines separated by nine specific field. There is a username, included password, last change, minimum is, maximum is, maximum is, warning period, inactive period, expiration date, or reserve. So these are that. If you see colon, then this is encrypted. Okay, so usually that. So another is etc/group. So it basically shows a group information. So these are the etc/group that is used in our user and authentication configuration. Now let's move to our another functionality of our /etc, which is our system and operating system configuration. Okay, so etc, one example of system and OS configuration function is etc/os release, which is inside our etc directory. So if you run this, you will see your operating system information. So just go do cat do etc os release. If you do this, you will see a operating system that is running in your system. So mine is Ubuntu. So these are your information. Another information is etc/fstab. Okay, so this fstab stands for file system table. Every time your Linux system boots up, okay, it looks at the file to figure out which hardware, disk partition, or USB network driver should be attached to a software folder. So its main job is, without this file, Linux wouldn't know where to find your file. It tells the system text partition A to treat it as a root directory, text partition B and treat it as a home folder. So it is basically a computer mounting roadmap. Okay, so it is basically that. So another function of etc is network configuration. So another configuration is a network configuration, that is that may be a host name or a host. So if you it is to find out the system host name. So if you do cat/etc host name, so you will see the host name of a machine. So mine is this one. So if you do similarly, if you do for host only, you will see your local name resolution. You will just see your local here host, I think is host. You will see you will see your local name resolution. Okay, so another functionality of our etc directory is service configuration. This is one of the most important. So each service usually has its own folder. The most first is SSH. So what is SSH? So SSH is a cryptographical network protocol used to securely operate network service, login, remote system, and execute command over an unsecure network. Okay, so it is basically used for logging into a remote machine, file transfer secretly. So it has two sides. So SSH has two sides. One is server side and one is a client side. So both are configured over our /etc/SSH. Okay, so first let us see for our SSH server side. Okay, so what we're going to do is so our server side is etc/SSH. So if you do this, my bad, so if you do this, see here you will see a bunch of SSH directory. So our server side configuration is done by SSHD. So basically it is done by SSHD. So here, even if you see SSHD, you might see config.d. So this d .d is basically a drop-in or a directory. You have to know it. Okay, so this is used by our server side configuration. This controls how your system accepts SSH connections, and our SSH client configuration is a simple SSH config. So this is the system that connects the other. This system connects to the other SSH server. Okay, here you will see a host key, like you see this is a host key. So you'll see a host key, which is this SSH host, RSA key, so these are your host key. It identifies a server, it proves a server that is identity to a client. So it's basically that. Here you might see .puv, right? Okay, so this is basically a padlock. These are like a padlock. These are a public, right? These are given to anyone. So here, if there is no extension given to a then these are private key. If anyone steals this private key, then they might impersonate as you. So these are the side. Another functionality of our server configuration now etc directory is our con. So what con does is, con does is it basically schedules, it is used for scheduling tasks. Okay, so if you run ls/etc/con, if you do that, sorry, it's con tab. Okay, you okay, my bad. Cron tab, I guess. Well, if you just do this, so this is a master schedule. If you open it, you will see a specific 7-column format that will look like a secret code. Okay, so here I'll show you. I'll run a cat command /etc contab. Okay, here you will see a bunch of files. So okay, you will see first, go over here. So this is basically this is your timing. So 17 asterisk, so it 17 refers to the 17 minute. Okay, and the asterisk refers to day, month, hour. It means basically everything. So this means the command runs at the 17 minute of every single hour. So another here, this is your root. So this is your user, basically a user, and a command user slash and run parse. So these are the commands. So cd means a change directory to cd slash means it change directory to root. It moves the process to the highest top of the folder tree before starting. This makes sure the script won't get lost. Okay, okay, and nn is basically this means only do the next part if the first one works, which is cd slash. So run part is this is a special utility. Instead of running one file, it runs all the executable file inside the folder. Okay, so // report, this is a talkative flag. It is the system don't print anything unless to log unless script actually has an error or something important to say. So basically that. And etc/con hourly, this is our target folder. So putting it all together, it says basically every hour at 15 minutes past the hour, switch to a root directory and run every script found inside a /etc/con hourly. Okay, if any error or something to report, then send to the node to a system log. It basically says that. So another function is systemd. So systemd is the service manager on a Linux. It is where you as the manager tell how to behave. Okay, so structure of etc/md. So it basically etc/system md. So basically structure of this, it is directory, right? So structure of this, if you do, so you will see bunch of folders. Inside this you will see folders of directories. So etc/systemd is the system. So this is where you okay, so system, right? So this is where you create your own service file or override. So and your user, this is configure for services that only run when a specific user logs in. Okay, another one is our general.config. This is a black box recorder for your computer. For example, I'll give an example. When our systemd is used. Suppose you have a service called Apache 2, a web server. A factory setting says it should start when your network is off, but you want to wait until your external hard disk is also mounted. Instead of editing a factory file, just add a new folder which is an etc.systemd and join system, right? In this system slash apache.2 service.d, you'll make a file override.config, right? There you'll write a unit. There you'll write a unit after equals to amd my data.mount. So when your computer boots, right, your system looks into your etc/systemd/system and it says an override.config file. It performs merge, and once you do that, your command will actually work. It will wait till your external hard drive is also mounted. So it basically it is a use of that. So another function of our /etc directory is security and permission. Okay, so here if you do ls/etc, right, you'll see sudo. You'll see a folder known as sudo. So what that folder does is, it is the most powerful configuration. So what it does, it is a list of who has the power. So basically, if you do /etc, right, sudo.d. So if you do this, you'll see a bunch of you'll see a bunch of people who has the power. So if you do sudo, right, sudo, you need a permission obviously. Sudo cat /etc and sudoers. Even if you just do this, you'll see who has the power to do. Here come to your you might see you'll see have a root all equals to all : all. So what this is known as a God mode. It ensures that the root user can do anything from anywhere as anyone. So it's basically that. If you move towards a sudo one, you'll see a percentage sign, right? So percentage symbol usually means a group. So instead of listing every admin name, Linux says if user is member of sudo, a group, give them a full power. It basically says that. Okay, so it is basically that. If you go there, you'll see a file @include dir/etc/sudo.d, right? It tells the system that after you read the main file, go back to go look inside the /etc/sudo.d folder and apply the extra rule if there is any. Okay, so it's basically that. So another file that is used heavily is PAM configuration. Okay, the PAM configuration. So PAM configuration, it stands for pluggable authentication module. It is the reason you can log into your Linux machine in many different ways, like fingerprint, password, SSH key. So why is PAM needed in older Linux? If you wanted to change how people entered, you have to write the code for SSH, you have to write code for login, you have to write for sudo program. But with PAM, this program don't handle it. It just authenticates it don't handle the authentication themselves. They just ask PAM. Okay, so it's basically that. So what is inside PAM? So PAM. So what is inside PAM? So PAM. Okay, so it is a directory. PAMD is a directory in our /etc. So if you run that, you'll see bunch of here. If you see here, you will see a bunch of files. So you might see a common auth, right? So the main rule for password, you might see a sudo, right? Here you might see a sudo, the specific rule for when you type sudo. Here you will see SSHD, which is SSH hardening. So you might see SSH hardening, the rule for remote login. You'll see passwd, which is the rule for when you try to change your password. So basically everything inside is your PAM configuration. So authentication, which is your authentication. So let's for example, let's explore our common auth. Okay, so here if you do cat etc pam.d/common auth. Okay, so let's come on auth. Okay, so if you do this, you will see here you will see a line, you will see line with a basically you will see line with a 4 path. Here auth success equals to success equals to default, and default equals to ignore, and pam unix left non-locked. So let's understand what is this pam unix.so means. So this is the standard module that checks password against your user slash shadow. Okay, that we discussed earlier. Success 2 is it's basically saying if you type your if password correctly, then you skip 2 line, go to your success part. And if it failed, if it fails, then ignore it, go to the next module to see if that one works. So it's basically saying that. So you'll also see a path like here. You will see auth success equals to 1, default equals to ignore, pam ss.so. So what so pam ss so our pam SSWJ, this is for our network logins. If you aren't a login local user, right, so this model tries to find you on the network. Okay, so you'll also see pam deny.so. so this is a safety net. If both pam unix and pam sss fails, then the code hits request site. That means basically a game over. You'll be kicked out as a user if you failed to if you are a correct user. Okay, so if you are a registered user, so if you bypass this, right, then you'll see a pam permit.so. so if you made it the past pam deny, then this mode will allow you to proceed. It's basically saying as then the user is correct, it gives you a thumbs and you are into your Linux machine. So these are the common directories that is used in etc/etc directory. So there are more directories that we have left to discuss. The major one are /home, /home is the major one to discuss, and /var is one of the most important. This will be covering in our next part. So thank you for listening, thank you for learning, keep learning. Thank you.